Welcome to part 4. In this part, we are going to be looking at similar polygons. Most importantly, we are going to look at similar triangles. Theorem number 2, 3, and 4 are on similar triangles. We are also going to do midpoint theorem, which we have done in grade 10. And the midpoint theorem, it's a special theorem on theorem number 1 that we are going to do in this part. We are also going to do theorem number 5, which is Pythagoras theorem. Before we can start with similar triangles or similar polygons, we want to start with congruent triangles. Now, let's look at triangles which are congruent. When the sides of one triangle are equals to the corresponding sides of another triangle, then the two triangles are congruent. This means that if PQ is equals to YZ, and if QR is equals to XY, and if PR is equals to XZ, then it means that the sides of this triangle are equals to the corresponding sides of this other triangle. Therefore, the two triangles are congruent. We say triangle PQR is congruent, and this is the sign of congruency. Therefore, triangle PQR is congruent to triangle XYZ. Why is that? Because the three sides are equal, side, side, side. Are the two triangles which are congruent when two sides and an included angle of one triangle is equals to the corresponding two sides and the included angle of another triangle, then the two triangles are congruent. This means that if AB is equals to EF and angle B is equals to angle E and BC is equals to DE, then we say that the two triangles are congruent. Now, when two triangles are congruent, it means that they are the same, they have the same shape and the same size. So it means that one triangle is a copy of another triangle. Therefore, that is why with these two triangles, we say that they are congruent, because one side and two sides and an included, and it must be included between the two given sides. Therefore, when two sides and an included angle of one triangle is equals to the two sides and an included angle of another triangle, then the two triangles are congruent. Therefore, triangle ABC is congruent to triangle DEF. Risen, side, angle, side. Side, angle, side. We normally don't put side, side, angle as a reason. We normally don't put this as a reason because as we are saying it, side, angle, side, not side, side, angle, no. Therefore, this is the reason of why these two triangles are congruent. Now, if two angles and a side of one triangle is equals to two angles and a side of another triangle, then the two triangles are congruent. Therefore, you can see that this angle H is equals to this angle M. This angle K is equals to this angle L. GK is also equals to LO. Therefore, the two triangles have the same shape and have the same size. Therefore, they are congruent. Therefore, triangle GHK is congruent to triangle LOM. Reason? We've got angle, angle, side. Angle, angle, side. We normally don't say angle, side, angle. We normally don't say angle, side, angle. No. It's angle, angle, side. As you can see, the angle, then followed by an angle, then a side. Here, we said it's a side, followed by an angle and a side. That is why they are congruent. That is why it's not a side, followed by a side, then an angle. No. Therefore, even here, it's angle, angle, and a side. It's not angle, side, and an angle. No. That is why we normally don't write angle, side, angle. Now, when the hypotenuse and one side of a right-angled triangle is equals to the hypotenuse and one side of another right-angled triangle, then the two triangles are congruent. If the hypotenuse and one side of a right-angled triangle is equals to the hypotenuse and one side of another right-angled triangle, then the two triangles are congruent. Therefore, triangle PQR is congruent to triangle VTS. Reason is 90 degrees hypotenuse side. We've got 90 degrees hypotenuse side. Here, the reason is just as simple as that, because we've got a right angle which has a 90 degrees, hypotenuse side. Therefore, this side and this side are equal. Hypotenuse and a hypotenuse are equal. This side and this side are equal. That angle and that angle are equal. That is why we said the two triangles are congruent, because the reason is 90 degrees hypotenuse side. Now, I want us to talk about ratio. If I have 1:2, 1:2 can be written as 1/2. This just tells us that a certain quantity is 1 unit to 2 units of another quantity. Therefore, we can write this ratio in this form. Therefore, fractions are ratios. Now, we are saying that when the corresponding angles of one triangle, of two triangles, when the corresponding angles of two triangles are equal, then the two triangles are similar. Similarity is different from congruency. Congruency, we know that the two shapes must have the same shape and the same size. But with similarity, we must have the same shape but different sizes. As we are going to continue with geometry and metric, we are going to see exactly that polygons are similar when they've got the same shape but different in sizes. So it means that one shape is an enlargement of another shape. As you can see, these two shapes have different sizes, but their corresponding angles, this angle is equals to that angle, this angle is equals to that, this angle is equals to that. Therefore, the two triangles are similar because triangle ABC is similar. This is our sign for similar triangles or similar polygons. It's similar to triangle XYZ. And why are they similar? Because we've got angle angle, angle. With congruency, we can't have angle, angle, angle and conclude that the two triangles are congruent. The only time we can conclude that the two triangles are congruent is when we've got side, side, side. But when we have angle, 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 then it means that the two triangles are similar. Now, when the corresponding sides of two triangles are in the same ratio, when the corresponding sides of two triangles are in the same ratio, then the two triangles are similar. Therefore, not that sides must be equal in this case. In this case, we have similar triangles if corresponding sides are in the same proportion. For example, DE here over SQ is equals to EG over PS, which is equals to DG over PQ. You can see that here I have DE, which is KZ, over my SQ, which is Z, is equals to my EG, which is KX, over my PS, which is X, which is equals to my DG, which is KY, over my PQ, which is Y. All these, obviously this cancels, this cancels, this cancels. Therefore, this over that, this over that, this over that is equals to K. Therefore, it means that the sides of these two triangles, the corresponding sides of these two triangles are in the same proportion or are in the same ratio. Therefore, the two triangles are similar. Therefore, triangle DEG is similar to triangle PSQ. Why is that? Because sides are in the same ratio. Therefore, we've got all the sides which are in the same ratio. Therefore, we can talk about side, 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 even with similarity. But it's not that the sides are equal. It's not that the corresponding sides of the two triangles are equal, no. But the corresponding sides of the triangles are in the same ratio. They are in the same ratio, as you can see. They are in the same fraction, as you can see. Therefore, the two triangles are similar. You will see that this will be angle, 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 will be our theorem number 2, which we are going to talk about in geometry grade 12. You can see that when sides are in the same ratio, and we've got similar triangles, then this is theorem number 3 of our geometry in grade 12. Now, theorem number 4 of geometry in grade 12, we'll talk about this, but we're still going to talk about these theorems. We are just trying to make sure that we do understand what do we mean by similarity. That similar polygons or similar triangles in this case must obviously have corresponding angles which are equal. Corresponding sides must be in the same ratio. And with similar triangles which are different from congruent triangles. Congruent triangles, we've just said it, that they've got the same shape and the same size. Similar triangles have the same shape but different sizes. The shape of one triangle is an enlargement of another triangle when it comes to similarity. So, theorem number 4 of grade 12, which will talk about the two pairs of sides of two triangles, two pairs of sides of two triangles, two pairs of sides of two triangles, if they're in proportion and the angle between the two sides are equal, then the two triangles are similar. This means that if FK over RT is equals to HK over RV are in the same ratio or are in proportion, which means that Fk, which is Ky, over RT, which is over Y, is equals to H, which is Kx, which is HK, right, over RV, which is X, is equals to K. Therefore, you can see that the two pairs of sides are in the same ratio, and the angle included between angle R is equals to angle K. Then the two triangles are similar. Therefore, theorem number 2, 3, and 4, as I've said in the introduction, that those theorems are similarity theorems, of which we're still gonna talk about those theorems, but we're still trying to show the similar triangles. How are they similar? And obviously here we say that triangle HFK is similar to triangle RVT, knowing that we've got side, angle, side as well here. The reason why we are saying that these two are similar. So it's either two triangles are similar where we have angle, where the corresponding angles are equal, or when the corresponding sides are in the same ratio, where we have side, or where the sides, two pairs of sides, are in the same ratio, and an included angle between the two sides are equal, then the two also are similar. Therefore, theorem number 1, 2, 3, 4, of which we are still going to look at. Now, let's just summarize what we've just said. Congruent triangles. Congruent triangles equals to same shape, and same size. Similar triangles equals to same shape and different size. Same shape and different sizes, different size, one and the same. Now, a quadrilateral is a four-sided figure. Your parallelogram, it's a four-sided figure, which is a quadrilateral. A rhombus is a quadrilateral because it's a four-sided figure. A rectangle is a quadrilateral, and a square. All these are quadrilaterals. But not only these are quadrilaterals, we're still going to talk about other quadrilaterals. Now, a parallelogram is a quadrilateral with opposite sides which are parallel. So we are talking about the properties of a parallelogram. A parallelogram is a quadrilateral, which is a four-sided figure with opposite sides which are parallel, and opposite sides also are equal. Diagonals bisect each other. Diagonals and a parallelogram bisect each other. This means that this side is equals to that side, which means that this side is equals to that side. They bisect each other, but not equally, because this is not equals to that, but they bisect each other. It means that this diagonal bisects this diagonal, where it means that it cuts this diagonal into two equal halves. Also, this diagonal bisects this diagonal into two equal halves, but they don't bisect each other equally, where we're going to say this is equals to that, equals to that, equals to that. No. Therefore, a parallelogram is a quadrilateral with opposite sides which are parallel. F of got A, B, C, D. Therefore, the properties are that AB is equals to DC, and AC is equals to BD. AB is parallel to CD, and AC is parallel to BD. Opposite angles of a parallelogram are equal. Therefore, C angle AB is equals to B angle DC. Also, A angle BD is equals to is equals to D angle CE. This angle, which is that, is equals to that. That's what we mean there. And this angle there, which is A angle CD, A angle CD, or D angle CA, D angle CA, which is equals to that angle there, which is A angle BD. Diagonals bisect each other. It means that AD is equals to, AM, I can put M there. AM is equals to MG, and CM is equals to MB. All these are properties of a parallelogram, where AB is equals to DC, and AC is equals to that. Opposite sides are equal. Opposite sides are parallel. AB is parallel to CD, and AC is parallel to BD. Opposite sides are parallel. Opposite angles are equal. This angle is equals to this angle. This angle is equals to that angle. Diagonals bisect each other. Therefore, it means that AM is equals to MD, CM is equals to MB. But they don't bisect each other equally, but they bisect each other. Therefore, this is a parallelogram vis-a-vis or vices rectangle. Now, also, in a rectangle, opposite sides are parallel. Opposite sides are equal as well. Diagonals bisect each other, but they bisect each other equally in this case, because this is equals to that, equals to that, equals to that. They bisect each other. So, since diagonals bisect each other equally this time, here diagonals don't bisect each other equally, but they do bisect each other, because this is equals to that, and this is equals to that. Here diagonals bisect each other because this is equals to that, also equals to that, also equals to that. Therefore, with the rectangle, the interior angles are 90 degrees with a rectangle. Therefore, the properties of a rectangle will still have, if this is A, B, C, D, we still have AB to be equals to DC. We still have AC to be equals to BD. We still have AB parallel to CD. We still have AC parallel to DB to BD. We also have C angle AB, C angle AB, C angle AB to be equals to B angle DC, which is equals to 90 degrees. Also, this is equals to A, so this is also equals to A angle BD, which is equals to D angle CA. All these, this is equals to that, this is equals to that, this is equals to that. All these angles are equals to 90 degrees. If I've got an M there, AM is equals to MD, which is equals to CM, which is equals to MB in this case. Diagonals bisect each other, but equally in this case. Now, these are the properties of a parallelogram and a rectangle. We are still going to talk about whether is a parallelogram a rectangle or whether is a rectangle a parallelogram. We are still going to talk about that. With diagonals, with parallelogram and a rectangle, they bisect each other, but not perpendicularly, not at right angle. They are not perpendicular at right angle. You can see this is not a right angle. This is not a right angle. So diagonals, even here, this is not 90, this is not 90. Diagonals bisect each other for a parallelogram, but not at right angle. Even here, rectangles, diagonals of a rectangle bisect each other, but not at a right angle. Therefore, we are still going to answer the question of whether a rectangle is a parallelogram or whether a parallelogram is a rectangle just now. Before we can answer those questions, let's talk about the properties of a rhombus. A rhombus is a parallelogram with opposite sides which are parallel, and all sides are equal. All sides are equal, opposite sides are parallel, diagonals bisect each other at 90 degrees in this case. They bisect each other but not equally at 90 degrees. This is going to be equals to that because this diagonal bisects this diagonal. And this diagonal bisects this diagonal, therefore this is equals to that, and this is equals to that. Therefore, the properties of a rhombus, if I've got A, B, C, D. AB is equals to BC equals to CD equals to AD, because all sides are equal. AB is parallel to DC, and AD is also parallel to BC. Now, if I've got A1, 2, 3, 4, A1, B1, B2, C1, C2, D1, D2. Also, opposite angles are equal. D angle AB, which is this angle, is equals to that angle. But we know that angle A1 is equals to angle A2, which is equals to angle C1, which is equals to angle C2. Also, angle B1 is equals to angle B2, which is equals to angle D1 equals to angle D2. This simply means that diagonals bisect the angles. This diagonal bisects this angle and this angle. That is why this angle is equals to that angle, which is equals to this angle, equals to that angle. Even this diagonal bisects this angle, where this angle is equals to that angle, which is equals to this angle, equals to that angle. Therefore, the properties of a rhombus, all sides are equal, opposite sides are parallel, and opposite angles are equal, where diagonals bisect the angle, where this is equals to that, which is equals to that. Since this angle is equals to that angle, it means that this angle is equals to this angle, which is equals to this angle, which is equals to that angle. Even this diagonal bisect this angle and this angle, therefore it means that this angle is equals to that angle, which is equals to this angle, equals to that angle, since these two angles are equal. Therefore, here we still have AM equals to MC, and DM equals to MB, and AC is perpendicular to DB. These are the properties of a rhombus, where the 90-degree angles, sorry, where the angles, the interior angles are not 90 degrees, like the parallelogram. The interior angles are not 90 degrees. And the diagonals bisect each other at right angle. Diagonals bisect each other not at right angle. Even here, diagonals don't bisect each other at right angle, but they bisect each other equally. Here, they don't bisect each other equally. Therefore, these are the properties of a rhombus. The properties of a square, all sides are equal in a square like the rhombus, and opposite sides are parallel. Opposite sides are parallel. All sides are equal. Diagonals bisect each other at 90 degrees, same as the rhombus. With parallelogram and rectangles, they look similar, but they are not similar. We're still going to talk about why are these two not similar from the definition of similarity that we are still going to introduce. Even here, they look the same. They are not the same. They are not similar as well, these two, rhombus and a square. But sides are equal. Opposite sides are parallel. Diagonals bisect each other at 90 degrees. And diagonals bisect each other equally here. So it means that this is equals to that, equals to that, equals to that. Here, only this is equals to that. But this is equals to that. So they don't bisect each other equally. But here they bisect each other equally. Therefore, a square is a rhombus with 90 degrees angles, interior angles. Therefore, it means that the interior angles must be 90 degrees. Also, this angle there is equals to this angle there, equals to this angle there, equals to this angle there, there. So these angles there, in this case, they are equal, and they are equals to 45 degrees. If I have, for an example, A, B, C, D. The properties of a square, we know A, B is equals to BC is equals to CD is equals to AD. Also, AB is parallel to DC. And AD is parallel to BC. Also, if this is angle A1, 2, B1, 2, C1, 2, D1, 2, angle A1 is equals to angle A2 equals to angle B1 equals to angle B2 equals to angle C1 equals to angle C2 equals to angle D1 equals to angle D2 equals to 45 degrees. All these angles are 45 degrees. Now, if this is M there, we know that AM is equals to MC, which is equals to DM, which is equals to MB. Therefore, it means that diagonals bisect each other equally. That is why this is equals to that, is equals to that, is equals to that. Diagonals bisect each other equally at 90 degrees. Therefore, it means that AC is perpendicular to DB. Perpendicular. Therefore, diagonals bisect each other perpendicularly. Therefore, these are the properties of a square. One might ask, is a square a rhombus? Yes, a square is a rhombus because all the properties of a square are in a rhombus. Opposite sides are parallel. A square is a rhombus. Opposite sides are parallel. Diagonals bisect each other at 90 degrees. Opposite angles are equal. You can see that because this angle is equals to that angle equals to that angle equals to that angle equals to that angle on a square. But this angle is equals to that, this is equals to that. Even here, this is equals to that, this is equals to that. Therefore, a square is a rhombus. But a rhombus is not a square. Why a rhombus is not a square? It is because a rhombus don't have 90 degrees angles. Therefore, a rhombus cannot be a square. But a square can be a rhombus because all the properties of a square are in a rhombus. Is a parallelogram a rectangle? No. A parallelogram is not a rectangle because a parallelogram does not have 90 degrees interior angle. The angle here is not 90, is not 90, is not 90. We know that a rectangle, the interior angles must be 90 degrees. Therefore, a parallelogram can never be a rectangle because it can never have 90 degrees angles. But a rectangle is a parallelogram because all the properties of a rectangle are there in a parallelogram. Opposite sides are parallel, opposite sides are equal, diagonals bisect each other, opposite angles are equal, opposite angles are equal. Therefore, a rectangle is a parallelogram, but a parallelogram is not a rectangle because of a parallelogram does not have 90 degrees angle. Even with a rhombus is not a square because a rhombus does not have 90 degrees angles. But a square is a rhombus because all the properties of a square are in a rhombus. Parallel sides, opposite sides are parallel. All sides are equal. This angle is equals to that angle. This angle is equals to that angle. Even here, this angle is equals to this angle. This angle is equals to that angle, which is equals to 45. Therefore, it means that opposite angles are also equal and diagonals bisect each other. Therefore, all the properties of a square are in a rhombus. We are still in properties of quadrilaterals. Let's look at the properties of a kite. A kite is a quadrilateral with adjacent sides equal. By adjacent, we mean sides opposite each other, next to each other. Sides next to each other. Therefore, it means that this side is equals to this side. Adjacent sides are equal. Also, this side is equals to that side. Also, the longer diagonal bisect the shorter diagonal. Therefore, the longer diagonal bisect the shorter diagonal, meaning that if I have KAR here, it means that ER is equals to RI because the longer diagonal bisect the shorter diagonal, meaning that this length is equals to that length there. Also, in a kite, K1, angle K1 is equals to angle K2, and angle T1 is equals to angle T2. Therefore, the properties of a kite are that the adjacent side must be equal. This side is equals to that. This side is also equals to that. Therefore, the adjacent sides must be equal. The longer diagonal must bisect the shorter diagonal, where we have ER is equals to RT there. And also, in a kite, this angle K2 must be equals to angle K1. Also, T1, angle T1 must be equals to angle T2. These are the properties of a kite. Now, we want to talk about an isosceles trapezium. Isosceles trapezium is a quadrilateral with one pair of opposite sides parallel and the other pair equal. Therefore, it means that in an isosceles trapezium, one pair of opposite sides are parallel and the other pair where they have equal lengths. Also, a trapezium, in an isosceles trapezium, S angle P, Q is equals to P angle Q R. And also P angle S R is equals to S angle R Q. This just simply means that S angle PQ, which is this angle, is equals to P angle QR, which is that angle. Therefore, this angle is equals to that angle, and an isosceles trapezium. Also, this angle there is equals to this angle there, and an isosceles trapezium. Therefore, that is why P angle SR, which is this angle, is equals to S angle RQ, which is equals to that angle. Also, in an isosceles trapezium, diagonals are equal, but they don't bisect each other. They are equal, but they don't bisect each other. Therefore, it means that PR is equals to SQ. In an isosceles trapezium, these are the properties that we have for an isosceles trapezium. An isosceles trapezium is a quadrilateral with one pair of opposite sides parallel and the other pair equal. This angle is equals to that angle there. This angle is equals to this angle there. Diagonals are equal. This diagonal is equals to that diagonal, but they don't bisect each other, these diagonals. One thing that I didn't mention in the kite, with the kite, the longer diagonal bisects the shorter diagonal at 90 degrees. That's what I didn't say. That in this case, TK is perpendicular to EI. Therefore, this just simply means that the longer diagonal bisects the shorter diagonal at 90 degrees. They are perpendicular. Therefore, that is why we said if the longer diagonal bisects the shorter diagonal, it means that ER is equals to RT, but it bisected at 90 degrees. These are very important when we are talking of similar triangles or when we are talking of similar polygons, as we will see just now.